Alright, let's give question 5 a go. So, in order to understand this question, you need to understand what this 5 on the inside of the function does. So basically, if I read this little sentence over here, it's basically saying function g of x is actually same as f of 5 of x. So f of 5x. So these are the same functions. So if we do these two functions, it will give you the same answers. So what we want to know is, first of all, this coordinate lies on y equals f of x. So we need to figure out the coordinates of the corresponding point on y equals gx. Unfortunately, we don't know y of f of x. We know f of 5x. So we need to make it work. We need to figure out what this 5 does to this original function, f of x. So let's go back to our notes and figure out what that 5 on the inside does. So here's our two notes that we really want to look at. As you can see, my notes already says which one's inside and which one's outside. So this is the notes I want to be looking at, the second box. So as it says, this factor k, I can't remember our number, maybe it was 5 or 3, I can't exactly remember, we'll go back. It affects it horizontally, dilates, by the scale factor of 1 over k, and these are our dot points. And I'm pretty sure ours was the first dot point because it was either 3 or 5, I just can't remember on top of my head. So it moves closer to the y-axis. So these are the things I'm going to write down first. Let's see if I can remember it. Hopefully you have your notes right in front of you so you can just copy it down. So what was it? So 5 of x, so k was greater than 5. So my scale factor, right, is the inverse of that, is 1 over 5. So it actually reduces, not increases. I think it was horizontal dilation. Let me just go back and double check that. And then from memory, I think it moves closer to y-axis. Let me just double check that I've got all of those notes correctly, because if not, I will draw something wrong. So it was horizontally dilated, it moved closer to the y-axis, a scale factor of 1 over k. Brilliant, done. I've got it right, I remembered it. Okay, so let's use these and figure it out. So basically what's happening is the coordinate will get reduced by a quarter. So that's what you need to do. All you need to do is write the coordinate, okay, so 10, 25, and reduce it by a quarter each, not a quarter, fifth each. So it becomes 10 divided by 5, which is 2, and 25 divided by 5, which is 5. So this is what f of 5x looks like. So this was f of x, right? These coordinates were that one, but when it's dilated horizontally, it moves closer to the y-axis and it becomes a smaller graph. So it becomes that. So that is just your basically final answer that corresponds to the point y of gx, because you know this is actually the same as, you know, this is actually the same as g of x. So we found that coordinate. It's just simply 2, 5. Let me just double check the answer. Is that what we had? Hold on a second. What did I do wrong? Okay, just be careful. I did something wrong. I realized it. You can only change your x coordinate and keep the y coordinate the same. Because if you imagine it, actually imagine this situation. Let's graph whereabouts 10, 25 would be. Let's say this is 10 and let's say 25 is over here, just approximately. So it was over here. So when I, squeeze it in horizontally, move it closer to the y-axis. So basically just imagine your hands, let me just use different colors. Imagine your hands being over here and you're pushing the graph towards this way, whatever that graph looks like. Okay, let's just say the graph looks something like this or whatever. We're squeezing it in and it will eventually look something like this, like something a little bit smaller. Oh, where did it go? So you have to imagine, you'd have to assume, because you're only squishing it horizontally and not vertically, you'd assume the vertical component, the y component, does not get affected. So that was my bad. You only actually get affected, the factor only gets affected by the x coordinate. So be careful. right? So let's just take a mental note of that. You can make a note of it as well in your book. So let's try B and apply that knowledge. So as you can see, I've kind of, tackled the problem, gave it a go, but my answer was a little bit wrong. I read the answers and see if it was right or wrong. One of them was wrong, so I kind of problem solved and troubleshooted of why my understanding was wrong. So you can do that yourself too, right? I can't always make correct answers as well, so I'm, learning as I go. I can make that little dot point. So, for this one, if you really want to write down horizontal dilation, keep y coordinate same. You could write notes like that to keep you, help you out for the next time so you get 100% of it correctly. All right, let's try the next one. B. Given that, your coordinate -5, -15 lies on the g of x. So this is now g of x. Find the coordinates of now f of x. Okay, cool. So we know that this is actually the same as f5x. And remember that going from here to here in A, we reduced it by 5, which is the same as timesing by 1/5. So in order to go the other way around, so in order to go this way now, because I've got this answer, I want to get the other answer, I will have to do the opposite. So I'll actually have to multiply by 5, not reduce it by 5. So think of it this way. You've got your coordinate. It's already being moved, dilated by 5, factor of 5. So it's been reduced, whatever it looks like. So let's get my coordinate ready. -5. So let's just say that's -5 and that's -15. So whatever that graph looks like, I'm just going to draw a random graph. Okay, that's been already reduced. So your original graph of f of x should be much more bigger. So it should look something, you've got your hands over here and you're stretching it outwards. You want to stretch it out, stretching it outwards. So you want to make sure your graph is looking something like this, much bigger. So remember that our y coordinates don't change, but it's kind of stretched much larger by a factor of 5. So all you have to do, remember we keep the y coordinate the same, so we learned from our mistakes. So all you have to do, sorry, I've run out of space here, but I'll write it over here, is basically times this x coordinate, which is -5, by 5. Okay, because it'll actually be over here rather than -5, which is over here. So -5 times 5 is -25. Remember to keep my y coordinate the same, so it'll be -15. And I reckon that's just purely the answer. Let's just go double check. It is. So hopefully that made sense. If you didn't quite understand it, this would be an important exercise to understand. So come see me. We can talk about it.